Welcome to The Bottom Line Up Front, the podcast that cuts through the noise to deliver distilled insights from today's most important technical webinars, presentations, and demonstrations. Designed for federal and military IT leaders, each episode breaks down complex technologies into mission-ready takeaways so you get the key points fast. Whether it's cybersecurity, cloud architecture, or emerging defense technologies, we highlight what matters most and how trusted integrators like ATP Gov can help implement and operationalize these solutions across your agency or command. No fluff, no filler, just the bottom line up front. Today's episode of The Bluff is based on a recent multi-part set of briefings from Palo Alto Networks, but we're going to be reframing it in a way that matters to you. It's all about operational risk, mission assurance, and how agencies can safely accelerate AI adoption without jeopardizing data, systems, or national security. And we'll dive into how to protect mission systems from prompt injection, data poisoning, agent and tool abuse, and runtime threats, with a special focus on Prisma AIRS and what it means for .gov and .mil deployments. So let's talk about the fast-moving strategic risks in government IT. That's AI security, AI red teaming, model security, runtime threats, and new risks emerging from AI agents using model context protocols. First, let's make sure we have a clear understanding of why AI security is different for federal missions. As our speakers from Palo Alto Networks emphasize, AI is already in your enterprise, whether you plan for it or not. For DoD, DHS, and civilian agencies, this means shadow AI is already happening. Sensitive data is already being fed into unvetted tools, and AI systems are making decisions with real-world mission impact. This also means that the threat landscape now includes jailbreaks, by pushing models to break policy, prompt injection, which is reprogramming AI through craft inputs, even via email or external data poisoning, which is all about corrupting training sets or RAG resources, and tool abuse in AI agents, which can be defined as agents executing commands, code, or accessing systems autonomously. All of these risks hit DoD and federal environments harder because data sensitivity is higher, attackers are nation-state level, agencies cannot tolerate model unpredictability, and MCP-based agents can unintentionally escalate privileges or access classified and sensitive but unclassified systems. With that understanding in place, it's safe to say AI is now both an attack surface and an attack vector. However, Palo Alto's Prisma AIRS creates a full lifecycle AI security framework. For one, it's designed to discover and inventory AI use, identify shadow tools, and gather all models, datasets, and agents. It also assesses the environment, scanning for vulnerabilities, analyzing supply chain dependencies, and can run automated AI red team tests. Prisma is more than just a scanner, it can also protect, and it does so by performing runtime inspections, along with prompt and response screening, permission enforcement, and implementing agent behavior controls. Additionally, Prisma AIRS can integrate with existing cyber stacks, and that includes Strata Cloud Manager, firewalls, your SIEMs and your SOARs, and secure access service edge visibility. In other words, it plugs into systems federal agencies already operate. It doesn't just bolt on to another silo. So let's discuss another use case. This one is referred to as the guardrail trap. Security inside the prompt is not security. And guardrails like don't access sensitive data or don't run dangerous commands are absolutely superficial. A simple prompt injection, even hidden in an email signature, can completely override it. For federal teams, this is especially dangerous because many systems now involve email-integrated copilots, database-connected agents, knowledge bases with mixed sensitivity levels, and fine-tuned models using live agency data. What this also means is that an AI can read external data, read internal data, and write externally, which now forms a lethal trifecta. What it also means is that it could trigger unauthorized data exfiltration, mission system modification, self-initiated code execution, and automated operational decisions without human approval. And there's one more catch. If an MCP-connected system reads from external URLs or datasets, prompt injections can enter through web pages, APIs, email, as well as PDFs, and even a single crafted value in a database could compromise a mission system. And in today's increased AI deployment proliferation, that means that AI systems in government may touch personally identifiable information, travel data, hiring pipelines, intelligence summaries, acquisition workflows, or even battlefield or logistics systems. In the end, a single misaligned model could leak or misuse all of this data silently. And this is why architecture and not guardrails must do the security work. How do we secure our models and ensure that they haven't been tampered with and detect any adversary manipulation? There's really four big concerns that have been emphasized in the briefings that we've attended. The first being model integrity. Has the model been altered, poisoned, or corrupted? Second, data trustworthiness. Is the training data intact, accurate, and protected? Thirdly, threat detection. How do analysts know when a model is behaving abnormally? And finally, governance and visibility. Who is using what AI and how? All of these mission concerns align perfectly with how Palo Alto Networks has positioned Prisma AIRS. Prisma is all about asset scanning and detecting tampering or malicious additions to third-party models. Posture management continuously checks deployed models for drift, misconfigurations, or over-permissioned agents. AI red teaming simulates attacker behavior at scale and often generates hundreds of thousands of tests automatically. And moreover, Prisma's runtime security monitors live prompts, tool calls, and data flow inside the environment. This also creates a situation for cross-agent escalation where multi-agent systems can bypass constraints by delegating tasks, especially when permissions have been softened. For federal leaders, Prisma answers the biggest question: how can we trust the AI we're responsible for? As we dive deeper into Palo Alto's technical briefings, we also highlighted four major attack classes. First being prompt injection. Attackers don't break in, they convince the AI to grant access or take harmful actions. This is especially dangerous for agents that can read documents, pull from databases, execute code, and send emails. Second is data poisoning. Adversaries can modify training sets, knowledge bases, internal wikis, RAG sources, and the model begins producing completely tainted outputs. Third is jailbreaking, which bypasses safety guardrails and leads to misinformation, harmful output, and policy violations. And finally, agents that can take actions are at the highest risk. If an AI can write code, run code, read email, query databases, or trigger automations, it becomes a high-value attack surface target. All of this leads to a larger conversation about model context protocols and how they're becoming a standard for connecting AI agents to tools and data. You have to remember that an MCP acts as a connection layer or an API translator. It is the instruction manual for how an AI agent should use a tool. But here's the catch. MCP tool descriptions are written in natural language, and anything written in natural language can be manipulated. So MCP's two biggest vulnerabilities are tool description poisoning. That means if a tool's instructions become tainted, the AI follows malicious instructions as if they were legitimate. And then we have permissions overreach. If agents have broader permissions than the user, you've created an AI-powered privilege escalation path. And when we boil all of this down, federal agencies are faced with three urgent AI security priorities. First being stop relying on prompt guardrails. They completely fail under pressure. You need to implement continuous AI red teaming before deployment and throughout the lifecycle. And you have to secure AI agents and MCP integrations, which can introduce new mission-critical vulnerabilities. This really is the moment where AI innovation becomes mission risk. So how do we fix all this? Well, as I mentioned before, the first step is AI red teaming. And AI red teaming is no longer occasional penetration testing. It must be continuous, automated, and contextual to the mission. And now you might be asking, so what are the critical differences from traditional pen testing? Well, first, AI systems are non-deterministic. The same prompt does produce different outputs, so you have to test repeatedly. Second, attackers don't need coding skills anymore. Natural language becomes the weapon. And thirdly, models learn as they go. That means inputs today change vulnerabilities tomorrow. And finally, AI red teaming must match real mission use cases. Without mission context, the results are completely meaningless. All that to say, Prisma AIRS automated red teaming runs from an endpoint inside your environment, that could be a workstation, a VM, or a server, and it can interact with APIs, toolkits, or prompt requests, and it adapts its tactics to your application's context. With all the modules selected that are available inside of Prisma AIRS, toxicity, jailbreak, prompt injection, policy circumvention, admin escalation, NIST map checks, and the list goes on, a full scan can trigger hundreds of thousands of interactions that can run in, say, less than 30 hours on a single nano instance. That's to say, this isn't a 10-minute smoke test. This is closer to OT&E for AI, and it uncovers issues that posture checks won't see by themselves. Using Prisma AIRS, we have two ways to enforce all of this. but sometimes it takes a combination to get the job done. The open approach is network-centric. That also includes Kubernetes, containers, and CNI chaining. Prisma AIRS inserts an inline security appliance at the pod and namespace level. All app, agent, model, and tool egress passes through for prompt response inspection and AI-specific controls. This is ideal for on-prem or tightly controlled clusters, and it's a single point of presence and has deep visibility. Another approach is a developer-centric method using API gateways. You would have to modify the app so that every API call routes through a gateway, whether that's on-prem, VMs, appliances, or cloud-hosted, and this is best for hybrid and multi-cloud missions and cross-domain interactions. Which one do you choose, and when do you use them? Well, if you have on-prem Kubernetes with local tools, favor network-centric. If you have distributed services across clouds, favor the API gateway. And you can do this in a mixed format, that being on-prem front ends with cloud tools, or use both for bidirectional visibility when you leverage Prisma AIRS. So what's the bottom line up front? AI isn't coming to federal networks. It's already here. Whether the agency deployed it or not, shadow tools, SaaS AI, and internal pilots are already creating exposure. And AI systems behave unlike traditional software. They're non-deterministic, easily manipulated, and highly connected, which creates new attack surfaces that traditional cybersecurity tools can't see. Prisma AIRS is Palo Alto Network's end-to-end AI security platform, covering models, applications, data, agents, and runtime behavior. And the most high-risk AI elements today are AI agents using model context protocols, because attackers don't need to hack your network if they can trick your AI into doing it for them. And for DoD and Intel communities, the mission challenge is clear. How do we secure the AI we're building and the AI we're consuming and the AI that our people are using? In the end, AI isn't slowing down, and neither are the adversaries. AI security is no longer optional, it's an operational requirement. That also means federal agencies must adapt quickly with architecture, tools, and partners who understand the operational realities of government missions. And as exciting as AI adoption can be, it's also extremely nuanced and complicated. So if you want help building a secure, mission-ready AI posture, please reach out to ATP Gov and our team of federal AI security experts so that we can connect you with the right people and the right tools so that you stay informed and mission-focused. Be sure to reach out to ATP Gov today at www.atpgov.com or email info@atpgov.com, or check us out on social media on LinkedIn. Thanks for listening, and be sure to subscribe to The Bottom Line up front wherever you get your podcasts, and stay tuned for more distilled insights from the front lines of tech and national security. So until next time, stay secure, stay mission ready.